now it works. I have no idea what happened. You go to the empty row and type 0.25, and this is going to be your answer, right? So 607.65 to 738.35. I think it's 2 decimals, but we are not there yet. Oh, nearest integer, sorry. So 607.65 is what? 608, right? 608. So this is 608. My prediction interval is 608. It starts from 608 and goes all the way to 738.35 or 738. So this is my 95% prediction interval. Right? The question is $650 an unusually high price? And so you have to see, where is $650? $650 is somewhere right here, right? So is this unusually high? And the answer is no. In this case, the answer is no. When I solved the problem in the morning, the answer was yes, because my value, the given price, was outside the prediction interval. In this case, because the given price is within the prediction interval, right? We say that the price is not unusually high. So we say the price is not unusually high because it is not above the 95% prediction interval. Keep in mind, you will get a different answer, okay, when you do the problem, right? So if my given value was 750, would it have been unusually high? And the answer is yes. It's 750. If my given value were 750, if this given value were 750, is this unusually high? And the answer is yes, because it's beyond the 95% prediction interval. Remember, prediction interval is wider. And when your value falls even outside the wider prediction interval, this is unusually high. So 750 is unusually high. And 650 is not unusually high because it's within the prediction interval. Okay, so keep that in mind because you will see a different option here. Okay, all right. So I'm going to write this as 608 to 738. All right, and that's the end of the first question. Okay. All right. So there is one more thing I wanted to show you, which you will see in the next question that I'm going to solve anyway, but since I'm on this one. Now this question did not require you to see this. If you look at my notes, you can still see my screen, right? Yeah. You see this lower and upper 95%, right, under parameter estimates? You don't see that here. Under parameter estimates, where is lower and upper 95? It stops at p-value. So this is how you display. You right-click, and in the parameter estimates, right? Anywhere in the parameter estimates. You right-click, go to columns, and check lower 95. Right-click again, columns, upper 95, and you will see the lower and upper 95% confidence. Okay, so it's not displayed by default, but it's there. You just have to right-click and show. All right, let's go to a harder question and a more lengthy question. I'm glad we got the quiz done. I may do one more quiz. It's okay, it's not illegal. I verified with the police department. It's not illegal. If I have time, I will. It's legal. I promise, it's legal. Read the question while I erase the board because you guys are well capable of reading it too. I don't have to read it out to you. All right. So this is a difficult question because you're going to use a lot of chapter 20 here and a lot of chapter 21 as well. All right. So if you remember, I said it in chapter 20 that the questions in your MyLab will tell you whether to use reciprocal or log transformation, right? And that's exactly what is happening here. You want to formulate a simple regression model with y as the natural log of profit and x as the natural log of number of accounts. So we need to use the log transformation here, right? So let's first copy and paste the data. That's always the first step. You guys can still see my screen? Yes. All right. So because for this you will need the screen. For the first one, that's okay. You can manage the first one. This is a difficult one. All right. And if you get a chance, do you guys have a class Discord? Everyone has a class Discord group or something. Do you guys have? Post it for your brothers and sisters who are not in the class. Help them out because they'll suffer, okay, with this problem. So if you can, post it. That way they have help because they'll suffer. This is a difficult one. All right. So first is we are given profit and number of accounts, right? We are given profit and number of accounts. But that's not what we want. We want natural log of profit. And we want the natural log of accounts. So how do we create natural log? That's your first step. So we are going to create a new column. And we are going to name this column as log of profit. Right? Or whatever you want to name it. Right? And then right click, formula, and then go to transcendental, ln is natural log, and select profit, right? And this is how you transform a variable into, right? And when we get to reciprocal transformation problem, I'll show that to you. That's in a later chapter, not right now. All right, now you have the transformed problem. Now I'm going to do the same thing for number of accounts. I'm going to create a new column, log of accounts. Click OK. Right click, formula, go to transcendental, ln, number of accounts. Click OK. Right? So you have log of profit, log of accounts. Now we are ready to start answering questions. So first step is to create a regression model, fit y by x, same as chapter 19. Log of profit in y, log of accounts in x. It's given in the question, click OK. Right? And then we're going to click on this red triangle, fit line. Chapter 19 over, right? Now chapter 19 is all over, right? Now what's the first question? The first question is, is the simple regression model a reasonable description of the association between two variables? So what are the conditions for simple regression? The conditions for the simple regression are, the first one is linearity. That is, the relationship between x and y should be linear. The second one is the constant variance. Third one is independence, if time series. And the fourth one is normality. We want to check if all these four conditions are satisfied. Right? All these four conditions are satisfied. Right? So let's start by checking linearity. Right? Linearity. Do you see any bending patterns in the scatter plot? Yes or no? What do you guys think? Do you see any bend? Answer is no. No is correct. So linearity is satisfied. Right? Now to check the other three, we have to create residual plots. Right? So this is how you create residual plots. This was also in chapter 19. So go to the red triangle, plot residuals, and you have a bunch of residual plots. All right? All right, now let's look at normality here. Normality, right? So if you look at the normality here, right, you will see that the dots are going in a slightly wavy pattern, right? They're going in a slightly wavy pattern, but it's not super bad, okay? Ideally, it is slightly skewed, not normal, But we are going to mark a question mark here. We are going to check if the other conditions are satisfied. All right. It can be loosely satisfied, normality, but we'll put a question mark here right now. Right. Let's look at constant variance. So for constant variance, you can look at residual by x plot or residual by fix. It's right here, residual by predictor. Right? It's the same. It's the same plot. Residual by x, residual by fix, it's the same plot. So in this case, because we don't see any pattern, clear pattern, we say constant variance is satisfied. Constant variance is satisfied. Let's look at independence. First of all, is independence condition needed? Remember, independence condition is only for time series. Only for time series data. Is this time series? Let's see. So if you read the question, you have read the question, and it clearly states here that the data is over past 2 years. So this is data over past 2 years, so data over time. So this is time series. So we should check for independence. And to check for independence, you look at the residual by row plot, and this is approximately random, right? So we are going to assume that the independence condition is satisfied, right? Independence condition is satisfied, right? Now for normality, let's finalize that. For normality, so as long as your sample size is large, and in this case it's 30, we can assume normality is satisfied. But you can also look at this condition in my notes. I've provided this condition, and this is one of the problems where you will use this condition for. Where is it? It's right here. If sample size is larger than 10 times the absolute value of Curtis's, right? And in this case, it is going to be true, but I'll show you how to get the absolute value of Curtis's, because you may need this, right? At least for your final exam, if not here. So this is how you can get Curtis's. So you go to this, you go to Analyze, Distribution, and go to the Y variable, which is log of profit. Click OK, and then you go to this red triangle for log of profit, right? And you select, you go to summary statistics, customize summary statistics, and then you will see a value called Curtis's. It's deep inside, right? And click OK, and now it's going to display the value of Curtis's, right? So it's 0.51, right? So absolute value of Curtis's is 5.1, right? And if your sample size is greater than 10 times, so this is what we are going to use. You may not need it for your homework, but if your sample size is it greater than 10 times absolute value of Curtis's. So absolute value of Curtis's is 0.516. So absolute value of Curtis's is 0.5166. You drop the negative sign. Times 10 is what? 5.166. Because our n, which is 30, is greater than 5.166. We say normality is satisfied. Normality is also satisfied, right? Because we saw wavy pattern, right? In the normal quantile plot, like you see, we saw a wavy pattern. So I was not too confident whether the normality is satisfied. So what I used is, one of the very rare times you will use this formula is this time. I'm glad we got to use it in the class. N greater than 10 times the absolute value of Curtis's. Absolute value of Curtis's is 0.5166. I just showed you how to get there, right? 10 times that is 5.166, because 30 is greater than 5.166. Normality. All right, let's move on to the main part of the question now. So this was part one. We say all the conditions are satisfied, right? All right, next. next is the elasticity of profit with respect to number of accounts statistically more than or less than or equal to 0.30? So for this one, now you will use chapter 20. In fact, that's all we are going to use from now on, chapter 20. So what is elasticity? We saw this in chapter 20. What is elasticity? Elasticity was percentage change in sales or Y variable divided by percentage change in price. That's the X variable. Now this is loose, okay? This is not a formal definition of elasticity like some of you might have covered in community colleges. So the formal definition would replace sales with quantity demanded and price with price, right? But that's loosely speaking, right? So we covered this in chapter 20, if you recollect. Percentage change is change in log. Percentage change is change in log. And we have log right now. We have log in this problem. So percentage change is change in log, right? The only difference here is our Y is not sales, it's something similar, it's profit. So we're going to replace our sales with profit. Right, which is Y. And your X is not price, but it's number of accounts. Number of accounts. And that's going to give you your elasticity. Right? But we don't have to use this formula because we have our model. Log of profit equals beta 0 plus beta 1 times log of accounts plus epsilon. Right? That's our model. Right? That's our model. I push this down just in case you can see. And we saw in chapter 20 that this slope, beta 1, is your elasticity. The slope, beta 1, is your elasticity. Why? Because it's a change in log of accounts and change in profit, right? And that's exactly what we want. Percentage change in log of accounts or change in log, right? Or percentage change in accounts, sorry. Change in log is the percentage change in accounts. And change in log of profit is the percentage change in profit, right? So what we want to do is we want to test this beta. This beta is elasticity, right? This beta is elasticity. But it's not so simple. So if you look at the question now, the question says is the elasticity, and I told you what is the elasticity. Elasticity is your slope, right? Is it more than, less than, or equal to 0.30? So our hypothesis that we want to test here is beta 1. Why beta 1? Because beta 1 is the elasticity. And we are interested in elasticity. That's why it's beta 1. So eliminate all the responses or all the options with beta 0. So C is not correct because it's beta 0. Beta 0 is not elasticity. D is not correct because beta 0 is not elasticity. So out of A and D, one of them would be the correct answer. So we want to see whether the elasticity is equal to 0.30 or elasticity is not equal to 0.30, right? And that would be our answer. So it would be option B. Click OK. All right, find the test statistic, right? So now we covered this when we looked at the notes. We saw that when you want to, let me close this, I need this. When you have a hypothesis with the right hand side, which is not equal to 0, right? This is not equal to 0. So this is a non-standard test. This is a non-standard test. This is a non-standard test. right? So for non-standard tests, we'll have to calculate the t-value, p-value, everything, right? And that's exactly the exercise here. So we have to calculate the t-values. T-value, the formula here would be b1 minus beta 1 star divided by standard error of b1, right? That's the formula we have to use to get the t-value. So where is this b1? The b1 is in jump, right? So I'm going to write these values down now from jump. So b1 is in jump, and here's the value. So you go to the jump output, you go to parameter estimates, right? And b1 is the estimate for the slope, which is go to the estimate column, log of accounts, it's 0.3668135. 0.366. I don't know what it was, I forgot. 0.366. I'm going to look at jump anyway. Okay, that's your B1. Your standard error of B1 is also in jump. Standard error of B1 is also in jump. And that's right next to the estimate, 0.077189. 0.077. So what is this beta 1 star? Your beta 1 star is your value in the hypothesis, and we saw this. This is your beta 1 star. This is your beta 1 star, 0.30, right? So I'm going to use this formula, and you have to use jump to calculate this. Calculator will not work because it will work, but you will need to find the p-value using this value. So I'm going to go to a new data table, add a row, add a column, label this column as a t-test statistic, t-statistic. Add a formula. It's longer than this, okay? There's a lot more parts remaining, okay? So we'll leave you for a few more minutes because there's a lot more remaining in this problem. All right, so your B1 is 0.3668135. Minus 0.30 divided by standard error 0.077189. All right, and click OK, and that's your test statistic. All right, round to 2 decimals, it's going to be 0.87, and that's what you're going to enter. 0.87. All right. All right. Determine the p-value. So now you can't say the p-value is 0.000 because you have to calculate a new p-value. So this is how you calculate a p-value, right? So where is my jump gone? All right. So to calculate a p-value, look at this t-distribution, and what is the nature of the test? This was in the midterm exam, so you probably already know, but if you don't, you will recollect very soon. Not equal to 0 means a two-tailed test. It's a two-tailed test. We saw this on the midterm, so no need to waste time on this. So now my test statistic is right here, 0.87. So 0.87 is going to be somewhere here. So my p-value would be in two tails. So I'm going to find the area to the right. And this is half the p-value. This is half the p-value, right? And then I'll double this. I'll double this. So this is how you find half the p-value. So you create another column, say half the p-value, p over 2. And right-click, formula, you go to probability, t-distribution, your q value would be t-statistic, degrees of freedom is going to be 30 minus 2. But this is going to give me the area to the left. I want the area to the right. So I have to do 1 minus. So double click, type 1 minus, click OK, and click OK. So this is half the p-value. But this is not the answer. I want the total p-value. So how do I get from half the p-value to the total p-value? I double it. But you did this all before the midterm. So now my real p-value is going to be right-click formula. I take half the p-value and multiply by 2. And that's your real p-value. Round to 4 decimals, 3941. So that's 0.3941. All right, so draw the conclusion. So now our hypothesis here, which I've messed up, our hypothesis here is beta 1 equal to 0.30, beta 1 not equal to 0.30. My p-value here is what? Is whatever it is, it's large, 0.3941, which is larger than 0.05, so we don't reject 80. Right? So when we don't reject 80, we conclude that beta 1, or elasticity, is not more than, less than, or not equal to 0, but it is equal to 0. So we say, do not reject 80. There is insufficient evidence that the elasticity of profit is statistically significantly more or less than 0, because it's equal to 0, right? And that should be the correct answer. All right, next. If the firm could train these sales reps to increase the number of accounts by 5%, would this be enough to improve the overall level of profits by 1%? So this is not an easy question to answer. So I'm going to write the model down. Right, I'm just going to go there. So this is a difficult question to answer. So let's write the model down here first. So log of profit equals 8.949 plus 0.36868 log of accounts. So the question is this. The question is, if I change my accounts by 5%, if I increase my number of accounts by 5%, what can be said about increase in profit? Would my profit increase by more than 1% is the question, right? So how do you interpret the slope here? So first, interpret the slope. So for a 1%, and this is not even the answer, but you start here so that you at least understand. For a 1% change or increase in number of accounts, for a 1% increase in number of accounts, profit increases by 0.3668%. So for a 5% increase in number of accounts, for a 5% increase in number of accounts, profit will increase by how much? You take the slope and multiply that by 5. But I'm not going to bother multiplying it because this is not your answer, right? What it expects is in the form of confidence interval, right? So this is where the confidence interval for slope would come in, right? So what you'll have to do now is go to your jump output. And how do I know this? Because you read the question, it says the 95% confidence interval for slope. So we don't want this as an answer. I wish this were the answer, right? But this is not the answer. So we have to go to the jump report, right click on parameter estimates, go to columns, lower 95, right click the parameter estimates columns, upper 95. And those are your values, 0.208 to 0.524. So we are going to say for a 5% increase in number of accounts, right? Profit will rise anywhere between you take the lower limit of the confidence interval 0.2086 and times 5. Remember, for slope we have to multiply this by 5. And the upper limit is 0.5249 times 5, right? Percent. So what you have to do is you have to take the lower and upper 95% confidence interval, multiply each by 5, and see what's the bound, right? And that's the starting point. So let's see what is it. I can easily use a calculator here. Jump is an overkill. I have to multiply 0.2086. Oh no, I'll take all the values. 0.2086986 times 5, and that's 1.043. So this is 1.043%, and this is going to be 0.5249284 times 5, and that's 2.62%. So for a 5% increase in accounts, your sales is, not sales, whatever this is, what is this? The profit is increasing anywhere between 1.043% to 2.624%. So the question is the increase more than 1%? So your 1% is right here. That's the threshold. That's your benchmark. So in the worst case, my profit will increase by 1.04%, which is more than 1. In the best case, my profit will increase by 2.6424%. That's much greater than 1. So the answer is yes. If you incentivize your sales reps to increase the number of accounts by 5%, then your sales will, or profit will definitely increase by 1%. Because in the worst case, it will increase by 1.042%. In the best case, it will increase by 2.624%. So this is enough information to answer the question, right? So the question here is, yes, because the 1% is below, 1% is below the 95% confidence interval for slope. When the confidence interval is multiplied by 5, we multiply by confidence interval by 5, right? So that's your answer. Okay. So like I was saying, jump is not it. Even if you knew how to get this in jump, there's no, you cannot answer this question without actually understanding this, right? So that's why I was saying, don't believe people walking on the street who pass the class saying that, oh, jump is hard. If you know jump, you will pass the class. No. Even with jump, you can get this question wrong, right? So keep in mind, it's not jump, it is understanding, right? Understanding. Let's go to the next one. So if a sales rep opens 100 accounts, what level of sales would you predict for this individual? So now, in this case, it says express your answer as an interval. So would this be prediction interval or confidence interval, right? One of the two. Remember I was saying in the beginning, for those who were there at 9, I said that the question is not going to directly tell you prediction interval and confidence interval. You have to actually understand. So because I am looking at the level of sales for a sales rep, right? I want to see the profit for a sales rep. This is going to be prediction interval, right? This is going to be prediction interval. So what I have to do here is, I'll close this. We are done with this part. We have to go to the jump output, click on the red triangle, and go to individual confidence limit formula for the same reason that I explained in question number 1. And now you'll see lower and upper 95%. Now the question is, if this individual increases the number of accounts by 100, so you have to go to the number of accounts column, type 100, and press enter, right? Your profit will increase from this to this. But this is not the answer. This is not the answer. Because notice, what have we done? We have changed profit to log of profit. So what we have here is log of profit. Notice if I enter these values, this is again, jump is not going to give you everything, right? You have to understand. So if I round to two decimals, let me enter this value and you'll see this is round, 9.64 and 11.635 or 11.64. And you will see, you can read this message. This is more than what you have time for, but I'll erase the board in the meantime. But that's not the correct answer, right? So you see, jump is not giving you the answer. You have to supplement it with your understanding. So we covered this in chapter 20. So what we have here is log of profit. What I want to get to is the profit. So how do I undo the log? We saw this, right, in chapter 20. How do I undo the log? By finding the anti-log. Anti-log. And the anti-log that we are going to use is EXP. EXP, function and jump, right? That's what we are going to use. So that's not the correct answer, even though jump gives us that, right? So what we have to do now is go to our jump, and we have to convert both these columns to profit, right? So I'm going to say lower. Oh, we are already out of time, huh? Yeah, I'll finish this. I don't want to leave you in the middle of the question. Upper, okay, upper. So right-click formula, you go to transcendental, you go to EXP, and lower 95%, here's your profit. And then right-click on the upper, formula, transcendental, EXP, upper. Now these are your actual transformed, untransformed sales. So this is your answer now. 15.373, I don't know, it says round to two decimals. Let's quickly do this, that way you can go to other classes, Word, wherever you want, copy line, wherever you want to go. Give me 1 minute, okay? 15.373, 124. And actually there is one more part after this, but 113, 086, 189. Yeah, that should be the answer. Okay? And then the last part. Would you expect the sales of about half the reps to be less than the center of the interval? And the answer is yes. So if your distribution is normal, which in our case it is, we check mark normality. So half of the sales rep will be below the center of the prediction interval, half would be above. And we'll say that yes, as long as the residuals are approximately normal. Yeah. Okay. Thank you very much. Okay. And, log out so that others can use the computer. computer.